Yeah.
Robert Reed, Civil Engineering. For the this building here, the Studio Gang building, with all those surfaces and the balconies coming out, what special wind considerations did you have to take into effect here in the Windy City?
Can you say the last part again?
What special wind considerations did you face? And how did you deal with it?
Can you hear me? Okay. With all the high rises going on in Chicago right now, you have to get in line to do your wind testing, and we got in line within the first 6 months of starting the design, and we just got our wind testing done this last summer. What we were interested in was the way that the balconies could break up the wind and because as opposed to a straight rectangle where you get this wind coming straight down the building, that we were expecting it to actually break up this pattern. But what we found out in our wind study is it did not, the scale was strong to be able to understand that detailed effect. So we only got our wind tests from what the pressures were at the top or at the bottom, and it really tested more like a rectangle, and we designed for that. But I think what would be interesting if we have these facilities here at IAT is if we could model it here and do at a bigger scale and find out more about what the micro effect of that is.
I'm just wondering, well, I thought the last two presentations you did a good job of talking about the building out of the box, it's not just in the right time, but part of the larger system, whether it's structural, whatever. I'd just like to ask what kind of cooperation you got from developers on this, marketing people, and the city fathers who are adjusted to seeing buildings as singular objects.
Who's that question directed to? Anyone?
Well, the response that we got was obviously very favorable. In that, firstly, it was well received by the public, and what it showed to us was that the public does care in terms of design and what gets built in their communities. In Toronto, especially, there's this aversion to height, and whenever we go into a public forum to present a new proposal, the first issue is height. Well, we haven't told you what the height is yet. Well, it's too tall. So that's the sort of reaction we get all the time in Toronto. But through this experience, no one ever questioned the height. People were commenting on the curvature of the building and the design and all these other aspects, but never did we hear anyone say it's too tall, it's 3 stories, three floors too tall, or 10 stories too tall. That never happened.
We experienced a positive reaction as well. The original PD for this project called for 2 towers on the combined site that I was showing you, and the 2 towers were much bulkier and shorter, so our tower just took the same floor area, and we made a much more slender tower, and they were positive. The city was very positive about that, because I think the access to light and air is much better if you can narrow the floor plate, and so we had a positive response. I don't think height is really an issue in Chicago at all, unlike your city.
I'd like to ask you one other thing. Are there any websites about Chicago high-rises and all that you would recommend? Just put in Chicago high-rises, or how do you do it?
There's that one that keeps Forest and skyscraperpage.com. is where I found all of the really good information, and it's accurately kept and up to date.
Question on the Moscow Tower. You mentioned you were trying to skip the distortion period. What did you finally come out with on that? It has a footprint similar to the Cross Century in Montreal that the distortion problems initially.
So you're asking what the distortion period wound up being?
Yes.
Well, the lateral periods are about 7.5 seconds, about 6. We also got our mental study back last week. Acceleration is comfortably below 15, which is sort of supplemental.
Other questions? My question is for Jeanne. On the Aqua Tower, you developed this language of wave and flare. Was there any criteria to where on the building these effects would occur?
I think the original, where are you? Oh,
You're right.
okay. The original design, we made some rather, maybe 6 different, all over the building, 6 different responses to the surroundings. And those were the major bumps on the facade. And then as we developed that further and got more specific with it, the criteria was the, size of the units per floor, so that, everybody would have some access to a terrace. So they had to become smaller in scale. And we also had the environmental criteria of needing deeper ones on the south. And I think that if you're talking about, the specific language that we developed, like the swell and the flare, those were just techniques to start and stop each event. So in other words, if there was a response to a certain landmark, we needed to be able to start and stop that bump. And so, either it started and stopped with a flare, or it was a wave that traveled across and connected to another one.
Thanks.
This is Tom, from Design Engineer from Seattle. A question about Moscow Tower. And we see the stable columns provide overall stability of the tower itself. My question is how was each wing stabilized out of the plane? And also, is the tower designed for seismic?
Well, if I understand the question, the floor diaphragm maintains the Y shape of the tower, and then the 3 wings of the tower and the central core all act as one. So we're relying on the floor diaphragm to stabilize.
So that each wing is further away from the core. How is that to stabilize the plane?
I'm sorry, I didn't hear that.
Yeah, how is each wing stabilized? I understand the overall structure is stable, but each wing also, each cell, you said it's only 60 meters wide, and how is that stabilized?
Well, again, maybe I don't understand your question, but in essence, the floor diaphragm maintains the Y shape. And each of those segments of the plane, each wing and the central core, are surrounded by rigid planes on all sides. So it's really 4 tubes that are linked together. And so they all act as one structure, stabilizing.
Okay, so each wing is the tube structure itself stable.
My question is for Jeanne. First, it's a stunning building, result very good performance in the format. But looking at the image of the building, To me, it evokes straight away an image of fins on a fan coil as such. And it looks like, from your structural details too, the cantilevering of the slabs, you've got a great deal of thermal mass hanging on the outside of the building, particularly in a harsh winter climate such as Chicago. As a thermal study, the energy use of that building in particular, some of the problems you have with maybe condensation, particularly in an apartment where you don't have humidity.
The question was, how do the slabs act like a radiator?
That's correct.
Well, the slab area that is, yes, we calculated the energy use of the building, and it surpasses the Chicago Energy Code, which was recently revised, because the fact that the area of the slab that's exposed is relatively small. But we do have to figure out how to seal the concrete to keep from having moisture, migrate through the concrete into the ceiling, like any concrete building would have to do. And so we're studying that now because we want to keep the building as raw looking as possible without, having it appear painted.
I'm Yosuke, a structural engineer. The design, the building of map is fantastic and interesting. So my question is, when the design present in public is sold out, it's a very good news. My question is, for that design of building, how much the cost up compared to the conventional one? I mean conventional one, that's box type building. If it's not much, I will buy one also. I hope.
It may be a tad more than 5%. I don't really know. It might be very cost between Moscow and Superior House Market, and here it's very, very difficult. It's a 2,000-foot building, so it's. Oh, never mind. I believe you were asking about the MAD building, correct? MAD, okay. That was good. You were close. You were close. The premium to construct is about, it's almost 20% more than the norm. The premium in the marketplace, in terms of price sold versus current pricing in the marketplace, is over 30%. So the benefit analysis worked in our favor for once.
Any more questions? Okay, then I'd like to thank all the speakers, and then we're going to have an announcement in a few minutes, but I want to thank everyone for a terrific session. I want to present the books to all the presenters from the council. And now David Scott would like to say a few final words for this afternoon.
Thank you, everybody. It's been a great day. We've had some great speakers and great discussion. We start tomorrow morning at 9 o'clock. For those of you coming to the Chicago Architectural Foundation for the cocktail party tonight, if you make your way straight there are 2 buses waiting outside. They'll take the first 100. There is meant to be a fleet of taxis ordered, but I have to say that we haven't had much success with taxis today. There is a map outside for those of you who know Chicago and want to take the red line into town. The green line is there. The green line is down at the moment, so there's no trains running, but the red line is working, and there are directions that will get you from here to the Red Line, and from the Red Line to the Chicago Architectural Foundation. So see you tomorrow. Thanks again to the speakers.